Okay, girls, so we're studying a new chapter today called coordinate geometry. It's also called linear relationships, okay? The first exercise is a revision of what you've done in year 9. So we need to be able to find the distance, the midpoint, and the gradient of 2 points or a line, okay? So let's have a look at the first question. So they've given you the diagram. Really, the only information you need from the diagram are the 2 coordinates, okay? So let's find the distance, midpoint, the gradient from that, okay? Because that's what they want you to ask. Just letting you know, these formulas are on the formula sheet, so you don't have to memorize them for the exam, okay? So let's do it. So if you got these 2 coordinates, label the first coordinate x1, y1, and the second coordinate x2, y2, okay? It doesn't matter if you had the coordinates swapped, as long as you label them x1, y1, x2, y2, okay? So let's just apply in the formula. So that's your setup. So x2 minus x1, that's just that minus that. Notice it has a minus 3, so it's 2 minus 3. Okay, the formula comes with a minus, so don't forget that. And then you've got y2 minus y1, which is 3 minus 0. Okay, so if you put this in the calculator, square root of 34, and in the options given in the exercise, it's got decimal points, so that's 5.8. So obviously, if they wanted the answer to be in exact values, you will need to break that down into simpler certs. But yeah, it's just decimal numbers that they want in this case. Midpoint just means the average of the coordinates. So x1 plus x2, so the first one plus the first one from each bracket. So minus 3 plus 2 divided by 2 because we're trying to find the midpoint. And the second coordinate of each bracket, that's 0 plus 3. And then if you simplify each of them, so divide by 2, that's minus 0.5. And this one is 1.5. Okay, that's midpoint. Now for the gradient, make sure you follow that formula. So y2 minus y1, that's 3 minus 0. And the next 2 minus x1, that's 2 minus 3. Okay, don't forget the minus. So that's 3 over 5. Okay, so that's a gradient. So those are your basic facts and how to use the formula. Now, a bit more extra though. Question 12, it says find correct at the nearest degree the angle of inclination of a line with gradient 3. So what that means as a diagram, you have a line and the gradient is 3. What they want you to find is that angle, okay? In order to find that angle, all you need to do, tan theta is equal to 3. So in order to find the angle, press shift tan that. Okay, don't forget to press this. That will give you 71 degrees and 34 minutes. Okay, the reason why you do shift tan, because if you go back to year 9, remember tan. Look at this triangle here. Remember, this is the opposite to the angle, and between the angle and the right angle is adjacent. So remember, tan is opposite of adjacent. Okay. But at the same time, the definition of gradient is rise over run. So in this case, the rise is the opposite and the run is the adjacent. So because they both have the same fraction, that's why you use tan to find the angle. Okay? Just letting you know the angle is always measured from the x-axis up that way. Okay? Which matters for this. So let's do the same thing here. So the answer is that. It says find the angle once again. Now remember, the angle that they want is always from the x-axis until you hit the line. That's the angle that they want, okay? But in order to find that angle, I need to know what that angle is. Yeah? So in order to do that, let's call that alpha. What you do, press shift tan 2 over 3. Don't put the minus over 3, okay? That's the technique here. If you press shift tan 2 over 3, in your calculator, press the degree button after that, you'll get 33 degrees and 41 minutes. So that means this is 33 degrees and 41 minutes. But remember, I want that angle. So if I want to find that angle, so theta is then you do 180, take away that, okay? That's the extra tip you gotta know, okay? 146 degrees and 19 minutes. Okay, so the angle you want is always from the x-axis until you hit the line, not that one. Okay, the reason why you obviously take it away from 180 is because remember, angle of a straight line is 180. So 180 take away that. Sorry, 180 take away this will give you the remainder. So keep in mind, if you have a negative, shift 10 without the negative and take it away from 180. So that's what that note means, all right? All right, let's have a look at 13a. So in 13, find correct the two decimal places the gradient of a line with angle of 60 degrees. They've given you the angle, they want you to find the actual gradient value. So all you need to do is just type in 10, 60, okay? This one's easy. So if you do that, that's 1.73, okay? Same thing here. Now you'll notice with 13b, it's 158 degrees. So do the same thing. So the gradient is 10, 158. And if you put that in the calculator, that's minus 0.40 to the two decimal places. You'll notice if it's an obtuse angle, your final gradient answer will be negative. But if it's acute, it will be a positive value, okay? And the reason goes back to this, remember, if it's an obtuse angle like we had here, the gradient will always be negative, okay? I'm going to go through question 10 as a guide, okay? It's a good question, the type of questions you get in an exam. Okay, so the vertices of a quadrilateral K, L, and P are that, that, and that. Let's label those coordinates. So K is 1 and 6, so 1 and 6, okay? It says draw the quadrilateral on a number plane, so we just need to link these up, okay? Now my diagram may not be the most accurate diagram because it's not to scale, but let's just have a look what it looks like. Okay, I think that's pretty decent, okay? It is meant to be a square, okay? So if you did it accurately on your grid paper, you'll find that it is actually a square. Question B, draw the quadrilateral, I've done that. Question B, yeah, that's a square, okay? Question C, find the gradients of sides KL. So they want us to find the gradient of that and find the gradient of PM. Okay, so I won't go through in detail, but what you need to do is if I want to find the gradient of KL, okay, let me write down the coordinates. So to find the gradient of KL, label x1, y1, x2, y2. And remember the gradient formula was this? Okay, so I'll do the first one. So in this case, your y2 minus y1 is 2, take away 6. Next 2 minus x1 is 7, take away 1. So if you do that, you'll get, so that's the gradient of KL, okay? So they want you to do the same thing for gradient of PM. And so once again, label x1, y1, x2, y2, and do the same thing, and you'll find that the gradient is also minus 2 over 3, okay? And then that leads to the next question, D. Find the gradients of K, P, and LM. So they want you to do the same thing for the other sides. And then for question E, what do you notice about the gradients of the opposite sides of this quadrilateral? The gradients are the same, okay? And what does this mean about the sides? So it basically means parallel, okay? That's what it implies. That's what it means, okay? Question F, find the exact length of each side K on P. So obviously this time we've got to use the distance formula with the square root for all of them. And then you, obviously if it's a square, your distance between each points are all going to be the same because it's a square, okay? So find the distance of one of the sides, and it should all be the same because we know it's a square. And then to find question G, find the perimeter, you know what to do, okay? Get all the sides, add them up or times it by 4. Find the area, side times side, all right? So make sure you do this question, okay? And give the rest of the exercise a go. And if you have any questions, let us know in the classroom. Thanks.